All right, welcome back, everyone. Build is over now, so if you see this live, you're now in the right spot. So keep watching. Today we have a few open issues here. All the red ones you want to tackle, except for the one in the middle, the binary format. I only want to do on Thursday. Let's get started on this one. Yeah, I don't think Nihal is here, but my hope is that Tara can talk to this. Let's skip it.
Yeah, it's better to skip it because I have no idea about it.
All right, then we skip this one. That's an easy one. And of course now I can't click on the secondary because it's hidden. All right, Steven, you're up.
Thank you. So, the server-sent events has become a very popular format, in particular for AI services to stream down their responses. It's used for other things as well, but it's gained a lot of attraction for things like OpenAI, Mistral, Gemini, and so on, all using this. It's a relatively simple format. It's just, as you know, as part of the stream, it's just for the most part a word like data : and then everything after that until the new line is the payload. And then there are variations on that. There can be other things instead of the data prefix. You can have, named events and whatnot. But we've had requests from a variety of customers and partners to have first-class support for this because everyone is implementing it themselves. You can see this in the Azure SDK. You can see this in Semantic Kernel. You can see this in anyone who has a client library for OpenAI. They all end up doing this manually. So the idea here is we provide basically a simple parser for you give it a stream, which could be the response stream from an HTTP client, or it could come from anywhere, and it turns that into a sequence of the events, basically parsing the structure and giving you back the data. What I've proposed here, I have a draft PR implementing it if anyone wants to look at the implementation. If you could scroll down just a little bit. Thank you. What I've proposed here is basically a static entry point class, SSE parser, where basically you call parse and you give it the stream. And by default, it'll be parsing it just for the UTF-8 payloads that you get back. So the specification states that everything is UTF-8 encoded. So we would just, by default, just decode the payloads into strings. But if you wanted to, you could provide a callback, a delegate that would take the read-only span of bytes, so the raw bytes that have been received, and allow you to interpret that however you want. So the default overload is just basically doing encoding.utf8.getString, but it could do JSON serializer.deserialize with whatever type you wanted. It could have a custom union type or a value tuple or whatever, and interpret the data and give it back. What you get back from the parse methods are basically an enumerable of these SSE items, which contains the data, that parse data, as well as the event type. Every event has a type. Every individual thing has a type. By default, it's message. That's sort of what's implied. And then you can specify anything else, any other string as the message. That's the gut of it. I have some open questions about how to expose certain things. So we've had requests for both synchronous and asynchronous enumeration, in particular for Azure SDK, which does both. They expose both sync and async. Initially, I had two separate types. One that was an async enumerable and one that was an IEnumerable. But in writing out consumption code for it, it didn't really seem to matter whether it was one or two. Often the type isn't even visible because you're just saying either for each or await for each. And so, we could have a parse method and a parse async method, but they're both effectively giving back the same thing. What really matters is how you iterate through it. So for the purpose of the proposal, I've had this enumerable type that is both IEnumerable and async enumerable. We could choose to change that if we want. So that's one discussion point. Another is the SSE specification allows for every event to have an event ID and a retry or reconnection interval. if one doesn't, it inherits whatever the last one received was. So if it doesn't have an ID, then it's, but ID 42 came 4 or 5 messages earlier, then the message also has the ID 42. And that ID is used to basically, if the connection drops and you want to reestablish a connection to the server, you can, as part of that system, you could say, oh, and by the way, the last message I received was 42. So keep that in mind when you start sending me stuff. Because these really end up then being properties of sort of the stream rather than the individual messages, I've put them onto the enumerable so that if you cared about them, you could go check the enumerable to see what the last thing was. We could choose to move it to each individual item if we wanted to. It felt better to have it as the enumerable, but that's another open question. Third open question was, there are some use cases that we're not sure how common they are, but where you want some of the items to be skipped, for example. And so in all of my tests and use cases for it, I have the item parser delegate just return information such that the consumer could then just ignore that T that was returned. Mm-hmm. But you could imagine that the delegate also had like an out bool for skip or an out bool for early exit or something, or a ref bool if we wanted. We could also choose to add that later with a new delegate type if we wanted to. And then the last question was just around namespace and packaging. So we want this to be available to support things like Azure SDK and Semantic Kernel and other partners that still require net standard. So we need some OOB distribution for this. And for the life of me, I couldn't find an existing OOB package that seemed to make logical sense. Mm-hmm. So we could just group it with something else that we already have, but I wasn't sure what that would be, or create a new one. It's basically, system.formats.sse.nutkeg, which is what I currently have in the draft PR. But I'm totally open to suggestions there on namespace, naming, packaging, etc. But net standard 2.0 is pretty important for everyone who cares about this.
Do we have to ship it inbox as well, or can it be standalone OOB?
It can be standalone. I mean, at some point we might want to pull it in if we have reason to, but at the moment we have no inbox consumers for this.
Right. I think at that point the standalone OOB is probably the most sensible thing to do.
And yeah, as was pointed out in comments, and as Tanner has alluded to in the past as well, the ambiguity of SSE is a little unfortunate.
Yeah,
well,
it is.
It's not ambiguous. It's everyone who doesn't work specifically with this one thinks the instruction set.
Sure.
It's colliding.
So I did a Google search and I have a really hard time finding a format specification for this. Who owns
I'll
this
grab
spec?
it. Hold on.
Is that open?
Probably Mozilla, but
okay.
I'll grab it for you. I actually have a link to it in the PR.
I think I'm fine with the names because they're all multi-word names. Maybe we should consider changing the namespace to server-side events or something.
Yeah, I think Chad also recommended WebSSE as an alternative name for at least the namespace.
I don't know, WebSSE sounds to me like a SSE for WebAssembly. I don't know.
Touche.
So I had a question about implementation here. What would be the semantics of creating a new enumerator from SSE enumerable? And would it be initiating a new connection every single time? And the reason I'm asking that... Sorry, go ahead.
Go ahead.
Yeah, the reason I'm asking that is I'm seeing this last event ID property, which sounds like something that belongs to an enumerator rather than an enumerable.
Right. So these would be enumerators if you could for each enumerators, but you can't. the way I have it currently defined is you can call get enumerator once, and subsequent calls to it will throw. This isn't owning a connection or establishing a connection. It's just parsing the stream that it was provided with, which could be a memory stream, a file stream, a network stream, the response from a HTTP client, response stream. So the establishment of the connection and the initiation of the HTTP request and all that stuff is outside of this. This is purely, okay, you've got the stream containing the data, now you want to extract the information from it.
And following up on that, is there a precedent on us having types implement both the async and non-async enumerables?
Not really. At least I can't think of any, which made me hesitant to do it. But at the same time, it didn't seem like it helped to do it a different way. Because in the typical use where you're saying, for each var x in parse, what determines whether whether you're async or not is basically the await for each versus the for each. So we could make someone say parse async and then have that tied in with await for each, or if they didn't say async, not have the await in front. But then you're sort of making them make two choices rather than one. So it felt to me like it was better to just say, like, if you want it to be async, you say await for each. If you want it to be sync, you say for each. But I don't feel strongly about it. If we really, want two copies of the enumerable type, one for async and one for sync, we could do that.
I mean, it may well be that implementation could be like this, but the APIs don't expose the actual type. And the reason why I'm saying that, I see that you've added a couple of properties, but I don't see how you would both await for each on SSC parser.parse, but also like store it in a variable so that you can read the last event ID or read the reconnection interval.
The 99% case, you don't care about those other two properties.
Should these be on the return in a different way with an out param, or maybe just store them on the individual envelope structs?
So they can't be an out param because they can be updated. They could be on the item. That's one of the issues I called out. But then it effectively either it makes each item bigger for things that are rarely used and that are sort of logically associated with the stream rather than the individual item, or you're basically delegating from the item. You still store it on the enumerable and you're delegating to the thing, and that then makes it difficult to have two different enumerable types because an SSE item needs to be aware of the underlying type. We could do that. We could choose to make them on the SSE item instead and just deal with the fact that the struct will be a bit bigger.
So this itself is not streaming, right? This is just a description for what you could stream. Is that right?
Sorry, I didn't understand the question, Emo. Can you elaborate?
Like,
what is this?
So you have this reconnection interval, right? But this is not for the actual parsing or doing the parsing, right? This is just describing what events the server might send. And then
right, so the server can send down for each event the server sends down. Basically, it contains a payload with data. It can contain an optional event type, which defaults to message if one wasn't provided. It can provide an optional ID, and it can provide an optional reconnection interval.
So, since those are optional, why are they non-nullable on every? Oh, that's for the entire enumerable, not the item, right? Sorry.
Right.
Okay.
If we were to put them on SSE item, we would need to make them. We would probably make them nullable.
Yeah, I don't think I've seen like the retry item type. Like, what happens? Can that happen midstream?
You can get sent that anywhere you want. It's like I said, it's pretty rare, but the server can send that whenever it wants, and basically it means if after that point the connection drops, it's recommending that the client reconnect after that period of time.
So would you check it like after you enumerated everything? Like, could it start out as like, could that value change after you get the enumerable?
It can change on each item that you receive. But the typical use would be you don't look at it unless you decide you need to reconnect, in which case you would look to see if the server recommended a particular interval.
And its last one wins, basically.
Yeah. Same with
And if
event
you-
ID. If you had to reconnect and you wanted to advertise to the server via whatever mechanism that it provided, that you wanted to, reconnect, that you had received 42, you would look at the last event ID to see what to send.
Right.
Is it possible that you didn't get an event ID?
It's possible that you received no event IDs. Yeah.
Right. And then at that point, it would return an empty string.
Yes, it's string.empty.
All right, so starting with a verb, I guess. Is this a binary or a text protocol?
Text.
Okay. Since parse is the verb we use for text and decode is the verb we use for binary.
It's all UTF-8.
Okay.
I mean, so I'm on kind of two minds when it comes to the async enumerable and the enumerable and the same type thing. It is kind of consistent how we do disposal now, right? Because you can basically implement disposable and async disposable, and you choose basically by prefixing using with either await or you don't. With this one here, I don't know exactly how many places we have in the framework that gives you an async enumerable. I don't think we have that many. But I thought that last time we looked at them, the methods that return you an async enumerable were also had async in the name. So it would be parse async, giving you back an async enumerable, and then you would say await that one.
Right.
The problem is it's of course ambiguous, right? Because there's also APIs that give you, let's say, an I read only list, and it's like, get items async, right? And then you would not async for each this one, you would just await the method that gives you back the data, right? So it's already kind of in this weird state where depending on where the asynchronous is it in the enumerator or is it in the actual operation, it gives you back the results in one go. That's kind of messed up. So I don't think there is a perfect answer. On the one hand side, I think there is benefit to say we would split it out and then say, if you want async, you do async. If you don't, you don't. And then, you have symmetry on the call side. But I also see the simplicity in this, where you just say, hey, if you just want to for each override, you for each override, and if you happen to be async, you do a wait for each. So that seems very similar to how disposal works, and that's fine. I mean, the question, of course, is how do people discover that? I think that's a fair question, but I don't know, like me using Writer or ReSharper, they basically say, hey, you're an async context, the method has an async equivalent, you probably want to use that one. And they do it for async disposable. They do it for method names that are there's another method with a name but with a suffix of async, right? And so that would be similar here. If we care to make it to advertise it, we would have a code fixer or code suggestions for that as well, which probably is better than just relying on the naming convention, because as I said, it's already ambiguous depending on what the method returns. You have to know where to put the await. So I don't know, I'd like the simplicity here that it's just one method.
Yeah, I'm a little weirded out, I guess, by not the fact that we have an enumerable and async enumerable together. Is that's like the parse verb doesn't actually parse, meaning presumably it won't fail because it hasn't done anything. All it's doing is wrapping the stream. And then we have, back to the point of, we have these two properties sitting on the thing returned by parse, which I'm fine living on the thing returned by parse. I just think it's weird that the thing returned by parse is itself the thing that we're calling enumerable, and is like, it feels like you want to return, I don't know, an SSE parser, and then that one either has an enumerable method or we go find the parser itself is enumerable. I guess it's, yeah, you want the T, which is, yeah, you can still call it SSE parser, I guess. It just feels weird that we're returning a thing called enumerable and then shoving extra data on it.
So then you would do SSE parser dot create, pass in the stream, you get back an SSE parser of T, and then that one could have last event ID, reconnection interval on it, and then it would have just two methods, enumerate and enumerate async, that either gives you back an enumerable or an async enumerable. Is that it?
That's probably how I would write it, yeah.
I mean, I kind of like that. I mean, the downside is you have one more object in the common case, right? Because you create the, the parser, it's one instance, and then another instance is the enumerator or the enumerable, and then you have the
so
enumerator.
The comments somewhere, first bullet, the ownership of the stream is not transferred, but this is still going to just be, this is a read forever state, right? There's no inherent stop, right?
Sorry, say again, Jeremy.
So when somebody gets, they have this stream, are they expected to just read forever? Like
by default,
does it end? Does it
by default, yeah, you read until EOF. Some formats, including what OpenAI does, is they send an explicit string of text, open bracket, done, close bracket. And that value of the data means stop consuming this further. I don't know why they do that rather than just EOF, but they do.
Okay, so the expectation is basically you're hitting a socket and the server side closes the socket when they've finished the current payload, or they're contacting you and they close the connection, whichever way it works.
Yeah. Okay. But this is where, I mentioned wanting the delegate to have out or ref bool arguments for things like you skip or done. Because if you're trying to handle that scenario, typically what you do is your T would actually be a discriminated union of something and, a bit indicating done or a bit indicating skip, and the callback would take the span of bytes, which is just referencing the underlying storage that'll be overwritten shortly. Parses it, returns the T, and then the consumer could choose to say, oh, I see this had the done bit set, so I'm going to stop enumerating. Or I see this has the skip bit set, so I'm going to ignore and just loop back around. So we could have the parser for those scenarios, like the delegate could just set those bits effectively, and then the implementation could look at them and do the equivalent. But I didn't know if we wanted to bake that in or not, because it is a specific use case.
Right. So not knowing what any of these events are, I could imagine a world where you're expecting mostly numbers, but maybe some extra telemetry context, and you're like, well, I said I'm parse of int, but I don't want to return like 0 for these telemetry things. I do want you to just like pretend they don't exist.
Well, and this supports multiple event types, right? Which presumably have different kinds of data. But everything could be a string if you need it to.
Yeah, I think it's where I got to the discriminated union for T.
Yeah, okay. Sorry. So I'm reading some of this issue too.
Would it be terrible if the object wasn't enumerable?
Right.
There needs to be something enumerable.
Well, so not actually enumerable, that it just has like next and next async on the object.
You want it to have next and current, but
well, this is again because you have the thing talking about what's the last event ID I've received, what's the reconnection interval, and then which is, to me, it feels like this is, especially because parse isn't parsing, it's just wrapping. So Emo said SSE parser.create. And that then feels like now you have the I want you to, move on to the next thing. It doesn't need to be bool next and current. It can be T next and task of T next async.
And was it the net standard target that made us? Is that going to be like if it left out the async enumerable or enumerator? Or Jeremy, what's your objection to async enumerable for this purpose of like you could call?
I don't think there's an objection as much as this is. I mean, if you look at JSON, for example, we don't represent the JSON reader as an enumerable, right? We represent it as a reader that is stateful, and you use the reader to advance. But I think where he is heading with this is that when you have control flow concerns, where you want to say, oh, based on the T, I may want to skip or I might want to, return something else. Then the problem with the current design is, the parser somehow has to signal back to the consuming enumerable that, oh yeah, you want to skip this or you want to, but if you just say here's a reader, well then the calling code is supposed to handle that anyway, in which case it becomes fairly natural to expose them just as a reader. Is that right, Jeremy?
Yeah, I mean, whether it's, I don't know that would be where you'd be able to put the skip, because the current notion of what's being skipped would be more or less of, I can't turn the next thing into the T that I'm supposed to produce, so please pretend it doesn't exist and move on. So that would be within next, it would say go pump it a second time without returning. But yeah, I'm really just looking at the combination of the parse method being enumerable but also having state, and while trying to figure out what shape that turns into in my head, combined with the fact that getEnumerator is not allowed to be called twice, makes me think really all you're looking for is a move or is a next/read/move on whatever method, and then that's what has the sync and async variants. It also solves all the cancellation token wrapping problems that we have with async enumerators.
The question is what the common case looks like, right? But
you get the thing and then you just say, while I guess the problem is you want the breaking to not be an exception, which moves you back to the enumerator boolean move next.
Is the cancellation token actually like a problem for async enumerable? Like I thought it worked reasonably well if you pass it into get async enumerable. Like doesn't that basically apply to move next async? And it's like more efficient, so you don't have to re-register every time. Yeah.
The caller, it works fine for the caller. The mechanism
works fine for the implementation as well. I don't understand.
Yeah, you got to use like an attribute if you do a method, right? But like, yeah.
I was just remembering or thinking back to the complexity of all the plumbing on the whiteboard of like, how does the cancellation token get from A to B?
Yeah, but that's all handled by the compiler.
Yeah. The work's still there. It's not exposed to the caller.
I like, async, for each async stuff. Like, I don't know.
I think the question is like, what's the right pattern? I mean, I think if we go down with a reader with two methods, then the reader could, read two things synchronously and then three things asynchronously and then go back to synchronous, which is probably not what you want either, would be my guess. I think you want either like a purely async or purely sync. Like you don't want to interweave them probably, depending on how the implementation for those things works. But I mean, they're largely equivalent, right? If your reader is just a sequence, there already is a type for this, right? That's basically what an enumerable is, or an async.
Yeah, Jeremy, at first I thought you were asking like, why is there the non-enumerable? Because is it just performance? Like if you have a memory stream, then it's faster.
I mean, Christoph is here, you can talk to this, but I think it's mostly that a lot of the calling code is in synchronous code, so you don't get to call async APIs.
I mean, our general design rule is if you have an async thing, have a sync thing, because your caller might not be async.
That's fair. Yeah. I've probably been poisoned by SQL core. But yeah.
We have both sync and async APIs that trigger basically return of these SSE responses. I think Steven had a comment that it doesn't make sense to initiate a synchronous call, HTTP call, and then give people async enumerable, because that's basically what OpenAI library today does. You initiate either sync or async call, but then you get async enumerable. Maybe we changed it, but yeah, in general, both sync and async would be useful.
Yeah, I think my weirdness is having a type that we call enumerable that has the extra state on it, and having the verb parse that doesn't actually do what it says it does. So that brings me to the static verb should be create to indicate, which explains why there's not a sync and async. It's not doing work yet. It hasn't actually read the stream. And then if we want to say that the SSE parser of T that it returns is just inherently enumerable and async enumerable, and that people are okay with that, then fine, I guess. Just usually we have the factory thing returns an object, then you ask the object to enumerate instead of it returns an enumerable object.
So
Yeah,
sorry, go ahead, Christoph.
One thing I worry about, like enumerables that implement both async enumerable and then the sync version, is that async for each is not something that many people understand, but they find for each and it just works. So for example, they call asynchronous OpenAI API to get the stream, and then because they don't know a wait for each, they just for each.
So the assertion there is it's easier to discover that you should be using the XX async method than it is to discover that you should be using wait for each. Is that what you're saying?
Yeah, I mean, like people just look at IntelliSense, then they find async method, and then because also async methods have existed for many years, correct? Like 15 years, versus async for each has not for so long.
I mean,
So that would be
async disposable, but yeah, I think the question is how do they discover that, right? But so are you basically saying if there's two different named methods, one is, let's say, called parse and parse async, one gives you back an enumerable, the other one gives you back an async enumerable, then you can't mess it up, because if you get an async enumerable, then the only thing you can do is await for each.
Exactly.
Yeah.
Having said that, there is a trade-off here, correct? Like then we need to have SSE enumerable async, SSE enumerable sync, and
or we take, instead of the object itself is inherently immutable, we have open enumerator and open enumerator async, or enumerate async and enumerate whatever.
And that gives you back an async enumerator, or well, that gives you back an enumerable, I guess. Is that what you're saying?
Yeah, that would give back a async enumerable or a enumerable.
And it makes it slightly less weird than to have the state on the returned object, because it's not the enumerable anymore.
But then it makes it parser dot create async dot
it'd be
open
parser.
async.
It'd be parser dot create, which gives you back an SSE parser of T, and then on that you can do dot enumerate events or dot enumerate events async.
And each of them give you back an enumerable, right?
Each of them give you back probably the same object, which will be written the way that Steve's proposal currently shows, but the API surface would then have broken apart for ease of discoverability of async or for each async versus.
And the properties at the bottom of the proposal here, those would be on the parser instance that you got back from create.
Yeah.
So it would be the same object, but instead of SSE, the signature would then be enumerable of T, or I enumerable of SSE item of T, or I async enumerable of SSE item of T.
Yeah.
Be worried about
I'm just taking Christoph's. People won't discover that they can slap an extra keyword in front of the keyword they already know, and that it works in this context, and trying to see what that would look like.
Yeah, I think it's a good point. Like, 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 I think it's a Yeah, I buy it.
Reasonable.
Like I do buy that a lot of people who probably wanted to call await for each would call for each given this as proposed.
It's fair.
So are you thinking?
If it was written like that, SSC parser would need to be generic and not static. Oh, I see you have a separate one. Never mind.
Yeah.
No, I don't think. I think line 23, Jeremy's proposing there wouldn't be any interface
Oh,
implementations
sorry. Yeah,
there.
that's
Yeah.
I thought that. Yeah. I mean, I like that it seems a bit cleaner in terms of responsibilities. But it does mean you have one extra line. And you have one extra. Might be fine too.
Like one extra dot in your for each, really. It's not. I think it's pretty okay.
Well, I mean, it depends on what you want to do. I think the question is if you say, you know, if you don't care about last event ID and reconnection ID, you just dot into it. But if you care, then you have to, you know, snapshot that guy.
Yeah, I mean, it depends if it's already stored in a variable or whether you're calling SSC parser created line, I guess.
Right.
Sure,
The path where of the assumption that you don't actually care about these extra properties, you just wanted to iterate it, is you would just say dot create dot enumerate async and have that be your for each target.
Seems fine.
And then,
Given that,
sorry, go ahead.
Given that SSC parser is now going to force one or perhaps even two allocations, should there be provision for these to be reused for new streams?
I mean, the objects are small, and we can probably make the ref CS say it has no interfaces, and the implementation say it has interfaces, and enumerate says return this. Like, but the 40 bytes of creating a new object is
Sure, but
not worth
we ended
eliminating.
up doing the same thing for CBOR writer and CBOR reader because people wanted to avoid incurring a new allocation for every single time that they were writing or reading data. So I'm asking, should there be APIs for retargeting to a new stream?
Well, do we have similar APIs for like HTTP client responses that allow that kind of pooling? And furthermore, like these are not your typical HTTP responses. These are very long running HTTP responses usually. So
What did you have in mind, Eric?
I don't know. The first thing that jumps to mind is some method that lets you specify a new stream and resets the object and configures it to use the new stream, basically.
okay.
Like that?
Yeah, let me check what CBOR has.
I think we just called it reset there.
We could add something like that later in theory, right?
Yeah.
But basically the idea is that you would use them if you reconnect the pooled object, basically.
As long as you want to use the same parser on it, yeah.
Yeah.
I mean, yeah, we believe we can add it later. That makes probably the most sense. But I kind of like go back to what Stefan just said. Like, do we actually think that that's a scenario? Because it does seem like these are, you typically you pull data for basically for eternity. So do you really need to pool those objects?
I certainly don't think it's the greatest cost involved here.
Yeah.
I mean, you typically have a response stream dedicated, an HTTP request response dedicated to this particular interaction. There's more overhead there than the 24-byte object.
Yeah. And then to your earlier question, so what interactions do you want from the item parser? You said you want to have a skip thing, but wouldn't that be something that you would just do on the enumable side?
There's probably another conversation to have first because Christoph was pushing on this in the chat. So the reason I have the item parser set up the way I do is you're getting these raw bytes, and then it's up to you how do you want to interpret them. And I wanted to avoid, and the implementation is, it's got whatever buffering it needs with rented buffers from array pool and whatnot. And so the only allocation is whatever you do yourself in the callback. So there's amortized zero allocation associated with the bytes, because it's just got a buffer that it's rented and it's reusing that over and over, and it's giving you a span over that buffer. I did it that way because I didn't want to hand out that span, like yield out that span. We also currently can't yield out that span, at least as part of an enumerable or an async enumerable, because it would need to be a ref struct, and you can't have a ref struct there. And even in .NET 9, when we fix that, you won't be able to do that on Net Standard or NetFX. So we could not have enumerable or async enumerable and just have a flat API like Jeremy was suggesting, where you get back a span to the underlying buffer, but that span will be invalidated or start pointing to bad data once you push the machine forward again. But it would obviate the need to discuss things like, well, should the delegate have Boolean, out bool, ref bool, because you're just getting back the span as part of, the consumer is getting back the span and can do with it whatever they want, if that made any sense.
Yeah, by the way, so I was commenting in chat. I think the API is good for majority of scenarios, and I also feel like, frankly, we would probably use it.
I hope you
initially. Yeah, definitely. we would use it because so far I don't kind of like see any blockers. What I was just saying is I kind of like wish PCL always shipped like the low-level API in case something, like we find the blocker. So like, we were discussing bools, additional things that I want to do. And I think a good strategy for the API would be I start with calling this parse method and I pass the delegate, you give me a span, I do whatever I want. But then when I run into a limitation, I just switch to the low-level API.
What do you think the lower-level API is here, though?
It's the one that is basically just an imperative API that gives me, like the next chunk. Because,
as a span.
Yeah, exactly.
Would it be stream-based, Bill?
What? No. What do you mean stream? You're saying would it read a stream from a stream?
Right, or would the input be a read-only span or something?
No. It would be stream. So I actually implemented like the parser that is now in Open API. I implemented it, and like Steve was saying that reading from streams, and I said, why don't we expose UTF-8 stream reader, basically an API that takes a stream and chops the stream into lines, but does it in UTF-8 and not UTF-16 like the stream reader. And Steve said that it's simple to do it.
No,
and
that's not what I
right.
said. I said it's not the hardest part.
Okay.
The one that's in the Azure SDK doesn't actually handle everything that SSC supports.
Yeah. That's true. But anyway, just reading from a stream and chopping UTF-8 bytes into lines, that's kind of riddled in landmines. Simple prototype is simple, but then you discover all the corner cases. So
right, but a UTF-8 stream reader is not sufficient for this purpose.
For as a general SSC parser, I agree. Yeah, but for Open API, they basically use just a very small subset. There's no reconnection. There's no it's a small subset.
But it's a small set. Like the messages aren't split across data elements. Yeah, if they are, then you have to throw away the intermediate pieces.
Yep.
Because I can imagine something that's like SSC record dot decode and takes a read-only span of byte and produces a struct that has range objects on it describing like I have no idea what the format looks like. So, but for PIM encoding, we did you can give me some bytes and I'll tell you the label lived here, and here's where the data segment is. I don't own your input, so I'm not giving you back a slice of your input. I'm just telling you, here's where you should slice your input to find your data.
No, I
But
think
then you need
the lower
the
level
original
thing.
span.
Sorry, go ahead, Christoph.
I was saying, but then you need the original span, correct? Like if the only thing that you're getting is the indices, then you need the original data. And as Steve
Well, that
was
was
saying,
what you passed in as the input, yeah.
well, okay, then you're not reading from a stream.
Right, but I'm saying I understand. I could understand exposing that. Once you're reading from a stream, now we have the very complicated, if we let you touch this data, when does it become invalidated? Which is where we get the, like, we don't return spans over internal buffers. We would have to allocate a copy, and then you would hate that.
Yeah, of course. That's what I was saying. The low-level API is probably dangerous. It's like for people who don't understand what's going on and don't do things. The only thing you're helping me is reading from a stream, chopping events into lines, even if one event comes into different separate buffers, correct? Because I read into a buffer and I didn't find new line. I kept reading. Now I have two arrays. I assume you will stitch them. But yes, I cannot hold to the buffer for too long. That's the implication.
Speaking of buffering, I think somebody asked this in chat. Do we need to expose some limits here, Steve?
You mean to prevent an arbitrary amount of data coming in and getting buffered?
Yeah, I don't know if the record format says nothing can be bigger than a single megabyte event or, whatever.
SSC has no limitation.
Right. So do we, assuming you're doing a single array with double and keep trying, do we just say when we /exceed int.max value that's our limit, or do we need to let there be some control of other maximums?
I don't know, Christoph, would you set a maximum if you could?
I don't think so. I mean, we don't know in OpenAI and the maximums.
We wouldn't in SignalR. Generally, it would be the client using this API, and it trusts the server. I don't think we limit it today with our internal implementation. And as far as I know there's some mention of oh, what if payloads cross data frames or whatever. And yeah, I know maybe SignalR would also benefit from a lower level API, but we would probably we're just trying to remove the framing because SignalR has a transport abstraction already. So we just kind of shove everything into contiguous data stream every way. So T would be a byte array for us, basically.
Yeah, I mean, the implementation that I have, it stitches together. It basically has two buffers. It's got a buffer for reading, and it's got a buffer for if a payload spans multiple events, then it uses another buffer to stitch them back together. And then the span that gets yielded to you or handed to you is from that, is either from the reading buffer if everything was in a single event, or it's from the stitching together buffer if it was spread across multiple events.
What are the corner cases or edge cases or errors? What if you never see a new line? You keep reading from a stream and you don't see a new line.
So this is where Jeremy was getting at. If you just keep reading and you never see the end of the thing, then it just keeps buffering and buffering and buffering. Yeah. If the stream ends without the end of the event, then that gets thrown away. It's treated as invalid data per specification. But yeah, if you had if the server was just sending you an unbounded amount of stuff, you would just keep buffering it, waiting for the end of the thing to be reached.
Oh no, but it's a valid SSE stream, meaning there are new lines, everything is properly. It's just one event is super, super long.
Oh, then it'll just keep growing. It'll keep growing the buffer to accommodate it.
Oh, so you grow the buffer.
Yeah.
Oh, you don't. So you don't. I see. You don't have. That's how I imagine you would implement it. Like you would have two buffers, but most of the time you would be using just one. When you don't find a new line, you read to the second one and then you stitch.
So, well,
You never grow the
every
buffers.
every event ends with a new line.
Yep.
But multiple events can form a single payload.
Yep.
So if the implementation as I currently have it, there is a buffer that's used for reading and for basically for the current line, and that buffer always ends up holding the current line. And if it meets the end of the buffer and there's no more space and it still hasn't seen the end of the line, it'll grow that buffer and it'll just keep reading into that until it's accrued a line. If that line is then observed to be the entire payload, like it ends with 2 new lines, then that's it, and it'll give you a span to that read buffer.
Yeah.
If, however, it doesn't end with that because it needs to remove stuff in the between the payloads, it'll then move that data into the stitching together buffer and keep reading into the reading buffer, and it'll then stitch, append more to the stitching buffer until it's reached the end of the full event, and then it'll give you a span to what's in the stitching together buffer.
Yeah, I think that implementation is fine. I was just thinking that stitching buffer is different from the reading buffers.
Yes.
And I would have 2 reading buffers, not just 1. Because imagine that you read, you have a, let's say, 4K buffer.
Yep.
You read first event and it's almost 4K, but not really 4K.
Yep.
And then there's, 20 bytes of the next event in the first buffer.
Yep.
Now you don't find a new line, so you're saying you will resize. Is that correct?
So there was like a little bit less than 4K of one event that's processed, and then it gets the next 20 bytes of the next event. We're at the end of the buffer. Is that what you're saying?
Yeah, exactly.
It'll shift down the 20 to the beginning of the buffer.
Oh, it will shift them. I see. Okay, I understand now. Yep. Yep, that makes sense.
There's still the open question of do we want an API like similar to I have here where it's callback based and therefore you can't store the span and you kind of can't do the wrong thing, but it makes more complex interactions more complicated because your T needs to be a union or whatever. Or do we have the dangerous one that just gives you back the spans? There is no SSE item parser delegate. SSE item is itself a ref struct that can wrap the data and the event type and whatever else. But if you hold on to that beyond calling dispose or move next or whatever, you've now got a reference to something that's no longer valid and possibly someone else is using.
Yeah. As I said, I would definitely not remove the API that you have now with the delegate. But I just worry that sooner or later somebody will run into a case where, like for example, there's not just one T. There are many different events with different schemas.
Right.
And then you can either do a union or you have to, and unions only work if they are, like the overlap is very, well, you can then allocate on a heap and create a hierarchy. But like unions are can become pain in the butt.
Yeah, I mean, you can always just have it be object, and you're just allocating each, foo, bar, zoo, whatever, and they are all, and then you're paying for the allocation.
Yeah.
But I'm not entirely sure I understand, like, how do you, like, even if the item would give you the span as a buffer, why is it simpler than the callback mechanism?
It's not simple. Well, if you wanted to, it could, in theory, be more efficient. So let's say you had the data that you're reading based on the event type could either be a foo or a bar. Mm-hmm. So the SSE item parser, as currently written, needs to either allocate a foo or a bar and just give them back to you as object, and then the consumer casts back to foo or bar, or it gives you back a union of a foo or bar as a struct, for example. But then that struct is the size of foo plus bar. And so you're sort of paying a little bit of extra cost. I think Christoph, I think, is concerned about for an advanced user looking to eke out kind of the utmost in perf. If we just give back the span and the consumer can do with it what they want, they're not limited to kind of doing the production inside of the callback and then the consumption outside in the consumer. They can do everything in the consumer because they're just given the span.
So you're saying they could, for example, sniff test the buffer and then have two different code paths rather than having to create a type that represents both outcomes.
Or they might, if it's dictated by the event type, since every message has an event type. So the event type could be the string foo, or the event type could be the string bar, and based on that, its value, it then interprets the bytes differently. But it is a foot gun.
Right. Because the moment that move next gets called again, your span is still readable, but it's not your span anymore. Yeah. I like the way here. I think if we need something lower, that would be more like, SSE record or SSE event or whatever the thing calls the lower level concept, and then we would need to design the shape for that.
But again, like this solution has exactly same problem, correct? Like if you return a record that just describes the boundaries, like indices where stuff got parsed, then you also need to give people access to the original data. And then there is the problem of the lifetime of the data. The moment you want to eliminate the lifetime problem of the data, you have to copy.
That's a lot of ifs, though. Like by returning cursors into a data that you provide out of band, like, I mean, yeah, you can work your way into that problem, but
right,
well,
like,
is that really a usability issue? If you went through all the effort to return cursors, then yeah, it's like more manual.
I mean, it's a fair question, right? Because if you write, let's say, a for each statement over the items, and then within the for each statement, you're accessing the items buffer. I mean, that might be a problem as soon as you take for example the SS item of T added to a list, right? And then after your for each is done, now you're for eaching over the list, and you do something with those buffers, which are no longer.
Well, you wouldn't be able to add it to a list because it would be a ref struct in that case.
Well, yeah, it depends on how you expose it, I guess. But I think that it is a bit problematic, right. I think, depending on how you expose it. I mean, if you make it a ref struct, then you have other usability issues. I mean, we know that from the JSON reader APIs that they're very painful, but, and async becomes really difficult to do.
So to be clear, we're only talking about a problem that exists if you're referencing the original data, which is not really how this is, after you've done the parsing, which is not really the design of this, right? Like this is
right.
Yeah.
I mean, the way I understand it is like you have the problem when you try to be efficient, right? Which kind of means that you have to not create some sort of representation for the item. You kind of want to just look at the buffer. And that's kind of hard to do if you say you can only do it while you're processing the one item.
Well, system IO pipelines were meant to solve this problem.
Right, because you would basically keep peeking in until you find the end of the record, and now you have the buffer range of here's the whole record, and then you call it consumed, and now it's allowed to flush that buffer.
Exactly.
Which is why this SignalR client, right, just type reader creates from the HTTP response, a pipe reader that it uses for SSE parsing, because then, I mean, it makes the kind of growing logic easy that's happening internally in SSE parser, but
that's an implementation detail of the parser itself. That has relatively little impact. I mean, the only thing that would affect here is, are you returning a read-only sequence of byte?
No, that's not what I meant that system IO pipelines were meant to solve. What they were attempting to solve is the consumer lets the system, the parser, know when it's done with a buffer. So there's a lifetime issue, basically. It's not like completely goes away because the consumer can still make a mistake, but you basically tell the pipe when you are done reading, basically done
sure.
with the data,
Yeah.
and then the buffer can be reused safely.
Sure.
Right, and that could be that you get something like SSE event dot decode or parse or whatever that takes a pipe reader, and then it tells you, great, I read your pipe reader, it's got some state I didn't call consume. Here are the ranges of all the parts that you care about. Go deal with it. But I don't think we need to add it right now. I think it could be added later.
I mean, that's an interesting assertion, because I think it wouldn't work at the item level. I think if you want to do this in a pipeline-based approach, I think you would change the entire entry point.
No,
Because-
right.
Because
It would
the
be
whole
a
point
new.
is that you
It
invert
would
the
be a new
lifetime.
class called like SSE event, describing, because that seems to be what the primitive in this thing is a thing called an event, which would basically be it sounds like it would be I read until a new line and then have, I don't know, some pipe delimited headers or whatever goes on in the thing, and it would be like, here's where the event ID or the event type was, here's where the event ID was, and here's your event payload, party on.
Where payload would be a read-only sequence of byte.
Yeah, whatever it would need to do to say, here are the parts of your pipe reader that are representing your stuff.
Yeah.
I mean, well, I mean, so back to Crystal's original point, is the most common case then you would vary the T based on event type, because then you would get away with just a generic method on SSEI called parse.
The most, I would suspect, I mean, I'm biased because of singular. Christoph, is there more than one event type with these like OpenAI SSE streams or whatever?
Yes.
Okay.
Though some of them, I would need to go back and see what's happening now with assistants. We do have multiple events, but like, for example, we have event that comes with data, and then we have terminal event.
But they're not actually, they're not modeled using, at least last I looked, they're not modeled using the SSE event type. They're just, the payload is done. Everything comes with data colon.
Yeah,
Exactly, same in singular.
Yeah, the payload is called done. I was wondering, depending where we get access to it, we just terminate the stream. Oh, by the way, how do I tell the system to terminate the stream here?
End of file.
You would just stop enumerating.
Yeah, I think.
Yeah.
Well,
Oh, as the reader. Yeah.
Yield break.
So yes, I need to return. So I need to return. Yeah.
Right. So the SSE item parser would return a union of your actual T and a Boolean for done, and then the consumer would say if done, break.
Yeah.
So if your data is a string or whatever, then you would just get the data back and you would ask, is data equal to the string done?
Right.
Break.
The super simple case, if you're not worried about perf and avoiding allocation, is you just use the simple overload that gives you back SSE item string, which is just calling encoding.utf8.getString on each of the read-only spans. Or you could also do, if you wanted to still have the allocation but avoid the transcoding, you could do SSE item of read-only memory of byte, and then the callback is just doing to array on the span.
Sorry.
And then all those cases, you're paying for the allocation, but you're able to then consume it via the copy in the consumer.
Well, you could also write a custom SSE item parser that just asks, is the read-only span of byte equal to, if it's sequence equal to done U8, then return a pre-allocated string. And then now done actually has no allocation cost. It just has the like 16 register spills of returning a struct.
That's not, the concern isn't the allocation for done, it's the allocation for everything else.
Yeah. So why does done exist? Like, is it ever before the end of the file end of stream? Because if it is, like, you can't continue reading from the stream after using this API, right? Because like it might have overread. It seems weird that the client would ever exit early, kind of, unless there was an error.
Well, the thing is that we have to do something with done, correct? So like, let's say we receive the next chunk and we see the string done. well, what am I supposed to do in the parser that returns T?
No, Stefan's question is, what do you do after done? Like, what? Yeah, does OpenAI ever send anything beyond done?
Yeah, I'm saying, and I don't think they do. I'm just saying, regardless, it doesn't change the fact that it's like I'm not yet at the end of the stream. I received the string done. What am I supposed to do?
I mean,
There's no
default,
way.
I don't know. It depends on your T. You might have to create your own like union type, I suppose, right?
Exactly. So
I mean,
like, there's no way for my parser to say, I got the buffer that you gave me, but I have no T for you. So keep going.
Right. That's where I was saying, if we wanted to, this like my tests that support that scenario basically have a type called chunker done, and it's basically it's a discriminated union between a T and a bool. If we wanted to have that explicitly supported, SSE item parser, still using a callback, SSE item parser could have an additional ref bool done argument and an additional ref bool skip argument, which the callback could set, and then the implementation SSE parser would look at those and choose to yield or not based on those flags.
And if done is always at the end, you really only need skip, right? Like for this scenario, you just skip the done.
Well, unless the T is,
and then you're done.
Okay. But it depends what the T is.
Yeah.
If the T is a foobar, then how do you produce a foobar from done?
I guess it's another way to know that you ended the SSE stream gracefully. Like if you didn't see that message, you would assume you didn't.
I think Stefan's point is, if it says done, you would just skip. And in skip, you're going to have to return default of T anyway. And
Oh,
so
you mean
said skip this, and then there's probably nothing after done.
Oh, I see.
You would have finished
it was a
Yeah.
question of not whether to have those bools, but whether to have two bools or one bool.
Yeah.
I see.
Yeah.
And if you need, a stateful done, then your delegate is to a stateful function that done sets the always set skip.
Yeah, I guess the one downside is like if you think that the stream might end gracefully, but like basically truncate the SSE response stream, like done is a signal that you might want to look at the application layer to know that you got everything.
Right, but the way that this is designed here, taking stream, because we can't unread to a stream, the way that it would find out that it's done and needs to preserve its state for the next read, it's already overread and there's no going back. Like, yes, if it's a seekable stream, it could rewind.
Exactly, yeah.
And so I think if we care about multi-stream things, then we would come back with an overload of create that takes the pipeline, since we can roll that one back. But I think, again, we can solve that with an overload.
I was not thinking about the input being the pipeline. I was thinking about the output being the pipeline. Because the consumer can say, I'm done with the buffer.
And you would do this on a per item basis or on the entire stream?
Per event. Like basically I use, that's the hypothetical low-level API, correct?
Right.
Like if we wanted to have low-level API that gives access to the original buffer, doesn't copy.
Right.
Steven was saying, well, if I just, given how the system works today, if I just give the buffer to the callers, they can completely mess it up. There's no way for them to tell me that they are done with the buffer so I can reuse it. I'm saying instead of returning just a raw buffer like a spawn, we could give them a reader and they basically just read event by event, which we give them a sequence. And when they say that they are done with the section of the sequence, then we can reuse the buffer. But I don't know if it's worth it.
I mean, is there any reason why the parser can't have a method that gives you back a read-only span over the current thing?
Because I cannot store the span for later.
You can't store it for later, and I mean, it's honestly the same semantics as last event ID and reconnection interval, right? It's basically last one wins, and as you enumerate through it, the values will change what this thing returns to you. And then after you're done enumerating, you can just make the method throw and say you no longer get to ask for the buffer.
You're basically saying on SSE parser of T, have a public read-only span of char current span.
Something like that, yeah. And then you could say, instead of returning even a T, you can just say you have a generic method on SSE item, parse item, that takes a parser of T or whatever, right? Or sorry, an item parser of T, and then you can inspect the span and then decide which T you pass in for that on call, right? You can either pass the done thing and say, oh, if it's done, then do whatever you want to do, or otherwise call whatever you want to call, right?
Right.
And then we could combine those. Basically, you get this callback. You can either parse or you can say, I'm done with it. Like, I looked at it and I either did whatever I needed to do or whatever. Don't worry about returning it to the enumerator. Mm-hmm.
Our general rule on returning spans for helping with memory safety and predictability is we only return a span if it is a slice of a user provided buffer. So the notion that SSE parser reads from a stream and there's a public thing that gives you, here's what the span that I last passed into item parser looked like, that violates our normal memory API.
Right. We'd end up
guidelines.
calling it, dangerous, unsafe, beware dragons current span.
But I don't understand why. Why is it? I understand why it is in some APIs, but in this API where you get event by event until the loop loops.
If it's based on pipelines where you're indicating what you've consumed or not, and it's returning, I don't know, a pipe slice, whatever the hell that would be, then sure. But if it's returning, if we put a span exposed off of SSE parser of T, when you've pumped the enumerator again, you still have the old span, but there's new data in it now.
Yeah, it's unsafe in either case. It's unsafe with pipelines as well. It's just that there's an expectation with pipelines that you know what you're doing.
Yeah, and then you communicate. Oh, okay, I see, Jeremy. You're saying that somebody may not be using for each. They may be pumping a enumerator manually, so they can get two spans.
Well, you can get it either way.
Saved it in the local outside
even if you're using it with for each, you say, local span equals var local span equals property span.
Yeah, I mean, you can, but I mean, it's unsafe in the same way that doing certain things with a list of T that can cause it to grow are unsafe, right?
Well, yeah, but it's the same reason we put as span on collection Marshall instead of on list. I mean, I'd have no problem putting current span on SSE parser as long as we gave it a sufficiently scary name.
I mean, if we really wanted to, we could make it an extension method similar to what we did for list of T and put it in a different namespace, right? And then just call it good.
SSE Marshall.
Yeah, I mean, I'd want to see the actual code of a use case that it would be solving before I'd feel good about it, instead of just a theoretical concept.
I mean, even in Christoph, even in the Azure SDK today, like the parser you have, it allocates per item, right?
I
know the answer is yes.
First, we are using stream reader, correct? Like we are using stream reader to chop the spans. So I mean the stream.
So it's allocating a new string per line.
Yeah, exactly.
Line 12 in Emo's Markdown. You have a const off a generic type. Should that move to SSE parser, the non-generic type?
Sure.
Like, it's just hard to reference, right?
Yeah.
Because you'd say SSE item of string dot event type default, which is the same as SSE item of int dot event type default. So
yeah, that's fine.
Clearly use object. Yeah, I mean, so then I think we discussed this one. So I'm still not entirely sure like what the solution then is. Are you basically saying, for the simple case, you just have a T of a parser, it constructs the T, many people just get away with string anyway, and then that's where we are?
Yep.
Yeah, I think it's basically what's on the screen. with the minor tweaks we talked about. And then if we really find a need to allow for direct access subsequently, we add something.
You went too far, Emo.
All right.
It should go to the non-generic type.
Yeah, that was the whole point. One question I had is, someone instead asked, should the item parser delegate take a state? So that you don't have to
and thread it through the whole thing. So that
Right, so
would also be
create would have to take it.
Yep, that's. I mean, I'm not saying we should. I'm just asking, like, do you think that's a scenario we want to solve? Otherwise, you have to. I mean, presumably, right now you have to. You only have the closure over the creation of the parser, which basically would keep it alive for the entire thing. In which case, it's just one more allocation. I don't.
Right, or you are returning a delegate that is an instance function or an instance method off of an object that is already representing the state, but
right,
which is the same as a closure, but without the weird, like, your locals get captured in fun and amazing ways. Yeah, I mean, I think the answer is if people ask for it later, we could add it.
It just means we'd be adding yet another delegate, but
do we need a? Oh, we need a custom delegate here because net standard 2.
Yeah.
I was gonna say, wouldn't this just be a func once we get the?
If this was net 9, yeah, it would just be a func.
Okay, and then yeah, so do we want the ref bool skip / ref control flags? Once we're going to add 2 booleans, it should obviously be a flags enum.
I was thinking that maybe we start simple as this, and if I really want, to indicate that done is done, I just make a key be a tuple.
Right, well, because you can do T as a tuple. If you're returning a reference type, you can return null for done. If you're returning a int and negative numbers make no sense, then you can return -1 for, like, people can hide the doneness in there in the value they return. All right, so no targ and no control flags on the delegate.
Yeah, I'm thinking like this is pretty nice API, and then maybe there is a need for super low-level API, like the direct access to the buffer. Anything else seems to be like in the middle, has a potential of working for a few scenarios, and then never-ending trickle of requests because I need a bool, I need this, I need that, and we just keep going.
Yep. Line 7, did we want to rename the namespace to server-side events?
And then there was also a question about the prefix on the types.
Yeah. I think the prefix on the types I care less about because, I don't think they have a high potential of conflicting with anybody. I mean, there might be some confusion about what SSE means, but if you put it in a appropriately named namespace like server-side events, for example, I mean, it seems fine.
Well, that's part of it. The namespace is currently SSE.
Right. Basically, what I'm saying is if you just rename the namespace, then I think we can leave the SSE prefix on those types as is.
Yeah, I will remind people our general rule is we don't use abbreviations, but if in this case nobody spells out, or people generally don't spell out server-side events, if they just generally call it SSE, then that's our exception.
It's
basically we're always the last ones to abbreviate.
It's a bit like CBOR, right? It's the name of the format, right?
It's both. It's not like it's not like no one ever spells it out, but like SSE is like, if anyone's familiar with it, like they'll probably be familiar with it as SSE as well. But it's not like so long-winded like that people don't sometimes say server-side events.
Question.
Well, you do it by itself, right? But I don't think it's practical to use that as the type prefix. Server-side events
I
parser,
like-
server-side event item parser, server-side event item, like that. At some point, taste comes in as well, right?
It's close,
Yeah.
I think, on this one. But I like SSE.
Yeah, I think
Do
SSE
we-
is the fine prefix, but we should expand the.
So
Yeah.
server sent, not server side.
Oh,
Yep.
Oh.
Good catch.
server send or server sent?
You got it.
T,
It's
okay.
sent. Yeah.
With a T. Um,
Do we need the constructor on line 11?
And if we didn't have that, have setters on the properties?
I mean, users wouldn't typically create these. They would be handed over to them.
I mean,
Yeah.
my tests do it all the time.
I was gonna say I don't see a problem with exposing the constructor for artificial data injection and tests.
Just in case new properties are added in the future.
And new constructors would be added in the future.
Sure.
I think either we have the constructor or we make the properties settable.
Yeah, I think get set has the nice benefit that you only have to add one thing, right? Just a new property. If you go with the current pattern, you always have to add the pairs.
Yes, but right now he got to call it a read-only struct, which is virtue, and
That's
it's
fair.
2 thumbs up from Jeremy.
That's fair. I mean, mutable structs are not great.
And then the event type would also need to be nullable string.
Unless you make it init. Or required, right?
Required in it.
No.
So then we leave it as is.
Yeah. Do we think system formats is the right container namespace for it? I don't have a better answer, but I'm just. It feels less like CBOR and ASN1 than it does like Streamreader.
I round robined in my mind through system format, system net, and system IO.
I mean, it is a format, right? And I mean, it is a niche format. So I think, we use the system formats kind of for niche things. I think IO and other things we would use for like things that we expect a large chunk of people having to deal with.
Yeah, I think if we end up coming back and producing the, Christoph's idealized lowest level API for this, I think system formats would be right for that. So maybe it's right enough for this.
I mean, where would you put it? Like system IO?
I don't. Yeah, again, I said I don't have a better answer. It's just that the things in system formats right now are ASN and CBOR, and those are both. I have a file on disk that I want to read, and so it was this is kind of the file format is how we got the name of this namespace, and this is more like a protocol.
Yeah.
But we don't have system protocols.
I think we.
Arguably,
the name, but I mean, a binary format is something that might be used as a protocol as well. To me, format is kind of slightly bigger than protocol, I guess.
I mean, arguably, a large chunk of the format per se is abstracted away in the parser delegate. So I think of it more of as a protocol as opposed to a format. But
well, the delegate is the payload for the arbitrary data from the user.
Fair.
The structure is hidden inside SSE parser of t.enumerate.
I think the other question is I think the namespace really depends on whether do we expect that we will be adding accelerator methods on HTTP client and the works that consumes these APIs, and should that influence the namespace that we choose?
Wouldn't put it past us for the future. I mean, we kind of did that for JSON, which is also in a different. I mean, that's in system text.
Yeah, I mean, you could say system text.server-set events. I guess that wouldn't be terrible.
Yeah,
that feels weird.
I mean, I guess for me the mental question is: let's say we would add a CSV reader. Where would we put that? Would we say system.formats.csv? Would we say system.text.csv? Because it's a bit like that, right? It's a relatively simple text-based format.
Yeah, I mean, I feel like we had said if we'd had system formats when we made JSON, that it would have gone under system formats JSON. But given that we already have system text and we've already shoved text interpreters there, I think a CSV reader would probably go to system text. But this one, like CSV reader and JSON reader and ASN and CBOR, those all have the feeling to me that while yes, you can use them to read from content from the web, they also make sense, and they inherently make sense of I'm reading a file off disk. And this one doesn't make sense for I'm reading a file off disk. Like, yeah, you can get a stream to the file on disk, but your server sent events are never going to be a file on disk unless you're a unit test. So that's just where, to me, formats is a little weird. If the low level part would make sense of I have a BNF and I'm interpreting the BNF and I'm giving you the structured reading of that. This is the high level thing built on top of that. And formats I'm okay with. It's just weird enough that I'm asking the question. That's all I'm saying.
Do we have any other candidate but system text.server-side events?
I think system net would make more sense than system text.
Yeah, agreed.
Indicating this is really this is a thing you do in networking and nowhere else. But I'm fine with formats.
I mean, I don't have a super strong opinion. I mean, a quick look here at what we have in net already. Systemnet, cache configuration, HTTP formatting, handlers, headers, JSON.
Right. So I guess the
QTT. Yeah. I mean,
so thinking of layering, this is the higher level thing. If we end up hooking it up with some sort of ease of use extension methods off of HTTP request or whatever, do we feel that it looks more natural in the consuming code to say system net or system formats? Because system formats does have a suggestion of like you are doing something low level, right? So far today, like you're in interpreting bytes.
Sure.
So I think I might prefer system net for the high level. And then if we expose the low level, it can be in the same package, just in system formats, or it could also, the low level could live in system net too.
Yeah, I mean, the lower level isn't that much lower level. I don't think it would warrant a namespace change. I think where we put this, we would just put that hypothetical thing if we added it. And that might not even be a different namespace. It might literally just be, an extra property on SSE parser named appropriately.
I think either one works.
Yeah, whatever logic you have that powers enumerate up to the point that it calls the delegate. It's like that feels like that would be whatever the low level breakout would be.
I have one last question, and this is mostly for Christoph. Christoph, in the chat, we were talking about what the most common use for this would be. And I think I'd asserted that it would be string, and I think you were asserting that it would be read-only memory of byte, but maybe I misinterpreted. I'm wondering about line 23, what we want kind of the simple overload to be.
Oh, you're saying stream because you assume that that's the chat completion message?
No, just because it's, the protocol is UTF-8 bytes. It says everything is UTF-8 encoded, so that it's expected that the contents is text.
Okay, I answer. But we would never want a system string because that's just an allocation, transcoding, and then we have to interpret them, and then the text, and then we probably have to chop the text.
Right. Well, read-only memory byte would also be allocation.
Well, except it wouldn't be transcoding.
Right, it would
So
not have
it's
the
just-
transcribing, but would have the
yeah.
allocation.
Yeah.
But why would we ROM byte it instead of just returning an array then? Like if we're calling to array, why not just say, here's your array, have fun?
Could be an array as well, a byte array.
Yeah, but like we don't need the system string. It's not like, you know, we're gonna be doing like in some cases I can assume parts of the message will be JSON, for example, and then I want to use JSON, our JSON APIs to parse the JSON, and I definitely don't want a string. I want the UTF-8 text.
So your assertion is that the most common consumption for the simple case will be as bytes rather than chars.
Well, for I would say, you know, like somebody commented, I was watching the YouTube stream, and somebody was commenting in a lot of cases, you know, I will just use string. And I can imagine for a lot of people who, you know, for whom the allocation transcoding performance is not a big deal, string is so convenient. So I think we should keep the string returning API, but we in Azure SDK would use the one that takes the parser of T.
Right. Yeah. Okay. Yeah, I figured you would use line 24. I was just wondering. I feel like we should have line 23, and then it was a question of what the T should be for that.
Yeah, I think it's probably the string one is the most approachable.
As to the questions in chat about refstruct, allows refstruct, we can't do that for down level.
Yeah. That's what I was thinking.
Yeah. I mean, if you want it to be non-allocating, you still have to pay the copy cost, but you would pass in an instance-bound parser that has its own buffer, and what it would do with data is copy it and return, I don't know, the length. And then now you would just know where your buffer is to go interpret the data.
I think we go with what's on the screen.
Right. I'm saying in Christoph's state, he wouldn't need to return a UTF. He wouldn't need to return a byte array. He would use a bound delegate, or he should use a bound delegate, wrapping his own buffer the way that he wants to do, where he owns the ownership of it. And then he just copies from data into his buffer and then calls the UTF-8 JSON reader on his buffer.
Sure. Yeah. You mean the delegate is basically a closure with a buffer in it that gets copied into.
Yep.
Right. Presumably a growable buffer, but yeah. And then return something because you have to. So the int of how many bytes you copied. All right. 100 minutes seems sufficient. Ship it.
What to say? I think it took a lot longer than I thought it.
Sorry.
Well, I mean, it's not your fault. It's us for.
That's good. There's some good changes, man. Christoph, thanks for your input.
Yeah, thank you.
You better consume it.
I mean, yes.
I will. As I said, I wrote the first parser, and we actually had a bug. Steve helped us debug it. It was something. Steve, do you remember what it was? It was
it's something we have another issue open to have an analyzer for, which is that stream reader is EOF. I think that's the name of the property. It does blocking synchronous I/O. And the reader was using that unnecessarily, so it was an easy fix to just not use it. But it led to non-streaming behavior.
Streaming behavior, nice.
A super easy mistake to make given the API.
All right. Then I don't feel too guilty.
No, you shouldn't feel guilty at all.
Unless you wrote it.
Yeah, if you added streamreader.io as ZOF back in the day, then you should feel guilty.
No.
It sounds like Gronk.
Okay, yeah, for this one, I can talk about it. So this is about introducing APIs that allow in recording exception inside the tracing data, I mean, inside the activity object. This is actually part of OpenTelemetry specification. And the specification clearly defines the behavior about like while recording the exception. So it will get recorded as event inside the whatever the activity or the span they call it. And the event will have a name like exception, and it will have some properties or tags, which is capturing like the stack, I mean, and the type of the exception, and also the message of the exception. So this API is we are proposing here is just like doing that. I mean, like it's called the record exception, so it can record the exception. It takes the exceptions that need to be recorded, and it takes like the initial tags that you can add it to the event or that we are recording, and also it have the timestamp because like we're recording it as event, so users are free to provide a timestamp for this event. We got advanced scenario that some people in the community was interested in, which is they wanted to get hold of the exception object itself for doing some operations like, you know, mapping to the source code or something like this, because the information we record inside the event is not enough for them for these scenarios. I mean. So, and in the same time, we are trying to avoid holding on the exception object inside the activity itself for a couple of reasons. I mean, one of them is like the exception can be rethrown. So if it's rethrown, so the stack will change, and it will be holding like wrong data that we captured initially. And second thing is like the exception can be big. I mean, like, and we are trying to avoid like holding on objects that big enough inside the activity, especially about like if the tracing operation is long. I mean, so we will hold on that for a long time. So we are trying to avoid holding on the exception object itself, and to help the user with their scenario. So we are introducing a new callback inside the activity listener, which is like I'm calling exception recording, and we can talk about naming here. But this callback will be called every time somebody calling record exceptions in the activity. So this will give the chance to the users to listen to this event, and they can get the actual exception and can do whatever they want with it. And in the same time, we are not holding it on this exception object. Yeah, the callback, I mean, we define the delegate here. The callback will take the activities that it's recording this exception and the exception object itself, and a reference to the tags that match this exception. I mean, like whatever. I mean, like get passed to the record exception method, and also users can use this tag list to enrich the data inside this event. I mean, they can add more tags, they can mutate the tags. I mean, like adding some more details about this exception or whatever. I mean, yeah. So this is basically the whole thing here. We can talk about some people complained about like maybe the naming is confusing because the callback is called exception recording, while the API is called the record exception. But I'm seeing this is reasonable. I mean, but still, I mean, like some people complained about it.
I would probably call it exception recorder, but yeah, same difference really. I think my question would be, so how many listeners do you currently have? I mean, you can have more than one activity listener. Isn't that true?
Yes. Yes.
So what happens when you have more than one and they're all set in recorder? You Like, what does the activity get then?
Okay, so if you have multiple listeners, so we will call one after the other, and whatever the end, I mean, like if mutate something, so the last one will win. I put this in the notes in under the proposal here.
So they each get, so they don't chain the tag list then, basically. They all get they all start off with the same, presumably empty tag list, and then whatever is the last tag list.
No, I mean like
one.
whatever, if the first listener, I mean, added some tags, those tags will get passed to the second one. So it's kind of accumulating what.
But the order in which the
order will be the order of registering these listeners.
Okay, so it's deterministic from the perspective of the user. It's the order in which they're
Yeah.
registered in.
Right.
Yes, that works. So tag list on the record exception one and daytime offset, shouldn't those be nullable?
Tag list actually is a struct. I mean, do you want, why you need nullable?
Well, I don't know. Like it's the empty. I mean, a default tag list presumably doesn't work super well when you call, length on it or something, right? Because I mean, aren't they just wrapping something?
The default tag list is just empty tag list. Yeah. It's.
And daytime offset. I mean, usually the reason why you want nullable for those things is because the absence and the empty value might be ambiguous, right? Maybe somebody wants a timestamp of 0 rather than no timestamp at all, if that makes sense. But I guess in daytime offset it wouldn't make a lot of sense.
I'm not sure about like what differences here will make. I mean, like if it is nullable, what will happen? I mean.
Yeah, I don't know either. That's what I'm asking.
yeah. No. I mean, like no. It will not make any difference.
Okay. So then,
yeah,
they're as they are.
Yeah, I mean, it's unusual that we would let the 0 or whatever the 0 value of daytime offset is, which I assume is January 1st of
right
0 AD in UTC.
It's time dot minimum value.
Yeah, it's weird that would be today, but if you took default dot add 1 second, that's not the same as default dot add 1 second. But I don't know that it really matters. I would have expected it to be nullable, and then null would say use the current time, and anything else would be write down what I told you. Darn it.
Most of the time, people don't care about timestamps except if there is a specific scenarios you want to capture that. So I would say like default is okay, because like we have another type. It's called the event activity event, which is also taking this parameters. I mean, like timestamp, for example, and we are using default there.
Where does the timestamp go in the payload?
It's okay. So this API will create activity event inside the activity object, and the activity event will have name and timestamp and the tag list.
So when I call record exception with a tag list of 2 entries, and then the first activity listener that has the exception recording on it, the tag list that it will get is already the ones of the 2 tags in that are passed into the record exception method?
Yes, it will have the list that passed to the record exception. Yes.
Yeah, I think my only feedback would be I would change the delegate and the property to exception recorder, but other than that, it makes sense.
Yes, I'll be a lingual nerd and say they should be actor nouns and not gerunds, which is the same thing, but
yeah,
more stupidly.
The other
just to before we move, because like activity listener have other callbacks, we call it like is sampling and something like this. So we are using kind of like INGs, but I'm fine with either name. I mean, I'm just telling about like if we need to be consistent, or it doesn't matter? Or...
Activity listener has started and stopped, and should listen to.
And it has
so...
trace ID generator as well, which is a func of activity trace. I mean, usually we have a known, like a delegate that does parsing, you would call parser.
Yeah.
Right. Okay.
Because
yeah, that's fun.
It's the thing that does the thing. It's not the state of the thing.
Okay.
The other question I have is, so you don't really have any sort of record verbs on activity. You do have add though. Should it be add exception rather than record exception?
Okay, first about like we got the name record exception from OpenTelemetry. I mean, and add exception. Yeah, yeah, I think both of them will be okay. I mean, I'm not seeing.
But you can do multiple, right? If you can do multiple, then
yeah,
makes sense. If there's only one, then maybe set. But other than that, I think it's when you currently have add and set as the two primary mechanisms to get data in.
Yeah, add will be fine also.
Then I would probably call it add exception. Seems to be the most logical name.
And the callback will still be the same.
Yeah, exception adder is kind of weird, but
yeah, I mean the delegate is saying how to turn the concept of one into the other, so record seems fine.
When you could call it tagger if you wanted to, right? Exception tagger, right? Because you're basically parsing a tag list, and the only data that this thing can produce is tags. But
I was trying to make sure that like anybody sees the name of the callback in the listeners can link it to this method. I mean, inside the activity somehow. So to be I mean, like they know that like there is a method called the record exception, so the callback is called exception recording or recorder. So it's kind of like there is a link between both. But right now, I mean, like, you know, if we go with different names, I mean, it will be hard for users to link between the callback and this API. If it makes sense.
I mean, I feel like you record the exception by calling add exception. So the exception recorder calling add exception, like you find them because they both say exception.
Yeah. I mean, I think so. To me, the problem isn't so much the naming, because I think the naming is, the bigger problem here is that you have two different places, right? Basically, you have to register something on the activity listener that is somewhere in your code path. Then in a completely different part of your code, you call activity.addException. Presumably, when you call activity.addException right now and you don't do anything else, it just goes nowhere, right? Because nobody registered an exception recorder, right? That is probably the bigger problem than the fact that their naming was not aligned. And you just have to know that you do that, right?
When you add exception, it will add it inside the activity object, and it will be carried. I mean, so anybody aggregating the data, the tracing data, can access this data. I mean, the exception that get recorded inside the activity object.
No, but my understanding is that the only data that is being recorded is the text that the recorder produced, right? So if you don't register a recorder, then calling add exception presumably does nothing, right?
No. Add exception will always add some event inside the activity object, regardless if you have listener or not, right?
Okay.
So that the listener is only for advanced users or of like they want to get hold of the actual exception object itself, not just the data we put inside the event. So if somebody calling add exceptions and there is no listeners, it still will get recorded inside the activity event. Inside the activity object as event.
Oh, I see now. So basically, okay, so there's some amount of data that is always being preserved in the activity, no matter what.
That's right, yes.
And then there may be additional data that people want to write there, which is basically why you have the exception recorder, so they can still get access to the exception object, because activity, while it writes some data, does not actually write the exception itself.
That's right. Yeah, exactly.
Got it. Well, I mean, it's still kind of a, so that makes sense, because it means unless you care, you know, it's not a problem. You don't have loss of data. But then, yeah, same what Jeremy said. Like, they're both named exception. I mean, it's a, yeah, you have to know. If you have the problem, you need to know where to poke. That's
fine. I'm fine with suggested names. I mean,
yeah, if we're going for the, so if this is supposed to be the event pattern, the property on activity listener, the ing suffix means it's called before you would call add event. And if you want to say that it's called after you've called add event, then you would call it recorded.
Yes, so it's before adding the event. I mean, we have to finish all listeners before recording the actual event inside the activity. Right. So, yeah.
Yeah, I don't think we generally name the delegate types the ing versus ed. I think they're named er. So I think the delegate would be exception recorder. The property can stay exception recording because it's
okay.
Or we'd call it on exception recording.
I mean, in fairness, it's a bit weird, because if you go with an event-based pattern, then you have a very different API shape to begin with. So
yeah, I mean, it's mimicking event.
Yes, kind of, yeah, but yeah, I mean, all the event thingies have handler usually in their end, so it's er as well, yeah.
Yeah, that's why I couldn't think of what suffix we use, because we use the whole suffix word.
Yeah, it's usually a change handler or item paint handler or what.
Right, so that's why activity listener currently has activity started and activity stopped, because those are after start activity and stop activity.
Exactly.
And so then so the property as the simplified reduction of an event, I guess, yeah, would be exception recording.
Mm-hmm.
Or exception adding, but that feels weird. Yeah, adding exception.
I mean, in fairness, I think it doesn't really matter here. So the reason why in events it matters why you have it before and after is because you effectively, like, you think of the system as a stream of events, and you have to somehow order them in order to do things before or after other things happened, right? In this case, that's not quite what we do here, right? Like, what we do is you have a listener, and what we kind of want to do here is we just want to give people a way to record additional data. The order in, like, at which point this is being invoked is almost an implementation detail, right? So long as the data gets persisted at the right state in the activity, that's the outcome that you want. So in that case, like, the before after is kind of, it doesn't matter. Like, you could, the infrastructure will call it at the right time for you to leave the data in there. You don't have to know when that is, right?
Fair enough. So you want to just leave it as exception recorder and say that this is an exception recorder to call if add exception gets called. Okay, that's.
I mean, activity started and stopped, I think, is different, because you do additional work, in which case you have to know when they happen, right? But that's different here, right? I think it's, you just give additional data, so there's only one point when you can call it.
Right. Well, because presumably this takes tag list as a ref, because one of the things that this thing can do is change it before it gets written down, which means that it's not really an implementation detail that it's called beforehand. It's the API shape says you have a chance to modify this tag list before I write it down.
Exactly.
Yes.
So using the band prefix of on before, this is really on before add exception. But exception recorder is fine. I'll stop talking. I'll even help. I'll hit mute.
Oh yeah, the other thing we said.
Yeah, sounds good to me.
Okay. Did I miss anything?
We did talk about the non-nullable defaulted date time, and
Yeah.
that it was okay and consistent with this namespace.
And done.
Excellent. Thank you.
I think we're out of time unless you want to quickly talk about this one, because it seems just like a let's just do it kind of thing.
For the most part, it's a let's just do it. There's a couple questions. So the delegates, I think, are all just let's just do it. There's basically no downside. It's just on each delegate, putting an allows ref struct to widen what's allowed to be used with that delegate for each T. There are a couple functions in here which I think are no-brainers. We can discuss things like activator create instance or string.create, or any of the ones that take an arg, like string.create or concurrent dictionary that take a targ, allows ref structs on all those. Yeah, like the one in the middle of the screen there. So previously where we have to do workarounds for T state to be a span, now it can just be a span, which is quite nice. Same thing for the args and the other places. I have a couple things marked as open issue. Here for IEnumerable and IEnumerator, it is possible to mark the T as allows ref struct. And in certain situations, you could do this. Where it falls down is IEnumerator of T implements IEnumerator or inherits IEnumerator, and it has a current property that returns object. There's no way that you can have a ref struct T that works with that object current property. So like I have a test that does this and throws not supported exception. And I think that's the only sort of sensible thing to do. So that's open issue number one. And then open issue number.
You only have to have this problem if you try to implement the ref struct, right? It doesn't really make any requirements for existing.
Correct. No impact on existing use or new use. It's just if you tried to use a ref struct, you'd have to do something special from your object current property implementation for the non-generic IEnumerator.
And this won't allow yield return to return a ref struct because it wouldn't know to make the enumerator a special ref struct type, at least yet.
Correct.
Yeah.
And it wouldn't work even if it made a special ref thing. Well, this would not work there. So it'd be a very special thing that would work today. You have to basically manufacture it as part of your current.
I mean, I would say I would just, the same what you said before, it's just widening, right? It might not work for everybody, but for the people that it does work, it's nice if you can do it now.
Right.
And concurrent dictionary, your targ, that's the object or a targ state that's passed into the factory.
Correct. It's called its method. It's just passed into the callback. That's it.
Okay.
Yeah. The other open issue I have is one I went through everything in compiler services and interop services, and I think this is mostly a question for Tanner, if he's still here, or if they're still here. I put everything where it seemed to work, but I wasn't sure if it fully made sense. It seemed like, well, we should allow anything that would work at the IL level, so go ahead, but I don't know. I'm open for input.
Yeah, no, I think for Unsafe in particular, this all makes sense. There's a lot of places where there's been requests for it. There's unsafe bitcast is maybe one of those weird ones where we might want to consider whether or not we want that, just because bitcast we've tried to make it a little bit safer because it's doing an explicit value cast. And it was originally designed for structs. We know but the nuance here is that it's a bit like as object, where you know for a fact you're going to be reinterpreting a refs or an object type of T to an object type of U, and if the T isn't actually a U, it's undefined behavior. And so it's just that little bit of nuance where if we allow this, it allows a thing that we've kind of shied away from for bitcast so far, but which became more possible when we removed the prior constraints. So it's just a nuance, might be worth discussing more in detail to make a final decision around on that one.
It basically means you have a reinterpret cast on the ref T field, right?
Yeah, and if the ref T isn't actually the target U, then it can cause undefined behavior for a reference type T.
Wow.
So what would happen at all if you say bitcast of I don't know, UTF-8 JSON reader state to, I don't know, something with bytes? Like the ref can't go through that. The ref itself can't go through that interpretation, right?
Well, the bitcast literally just, it preserves the bits as is. So T from and T2 for bitcast have to be the same size already, and so that limits that helps ensure a lot of safety, because you can't interpret like an int to a long. So you could do something like reinterpret, or you could bitcast a span of byte to a span of long, and that's somewhat well defined. That's no different than memory marshal cast. But then if you did something like object span of object to span of string, where the object isn't actually a string, then that's extra unsafe and can cause undefined behavior.
Right, but let's say span is, I don't know, 12 bytes, and I have another 12-byte struct, and I cast span of byte into my 12-byte struct. The ref value, like the pointer that is the ref, comes out, or is that a casting error of you can't turn a ref into a non-ref?
Right. No. That works like as pointer, where it's effectively bit blitting the actual underlying pointer represented by the ref, and you just lose the GC tracking.
That's already the case today, though, right? If I have a T from and a T2 that are the same size, they're both structs. The first one contains just a regular reference, an object, and the second one has bytes. That works with bitcast today, right?
I'd have to double check. We had some blocks. I know we removed some of the blocks. So that may or may not work.
Okay, I mean it's on Unsafe, but and yeah. If I have so for both bitcast and the Unsafe as, if I have struct 1 has a read-only span of byte followed by a, I don't know, long, and the other one has a long followed by a read-only span of byte, that quote unquote works. Like it'll just be like, whatever, you're in a state now. But you have a ref to garbage.
Yeah, essentially, and so that you can have undefined behavior via that, and you could cause a GC crash if the ref happened to if the blitted ref happened to point into the GC heap, then that can cause a crash fail fast.
Fair enough. I'm just really the question was, is that a thing inside that's being weird and guarded, and is there nuance to this expansion? But it doesn't. The question is, should we let span of byte turn into span of char? And the answer is, who cares? All right. I'll stop talking.
There's one more issue that is not really specific to this proposal, but just the whole allows ref struct thing in general, which is if anyone inherits from an interface with a ref struct, which is now possible, you can now implement an interface on a ref struct. We basically can't add. It's a source breaking change for us to add a dim to that interface, which means it's yet one more place where dims become source breaking changes for us. Pretty much any interface we have, if we add a dim, if someone inherited it from it in a ref struct, it's a breaking change. We'll have to figure out if or how we want to do anything about that other than just messaging there be dragons.
Why is that? Is it because there's boxing going on with the dim?
Exactly, because if they don't override that dim, then calling the dim will box, and it can't be boxed.
Right. Okay.
Do we want to have an analyzer that helps point users towards re-implementing dims anyways because of the boxing problem? I know it won't solve it, and you can like blow up at runtime in that case. But maybe it'd help direct users away from that pit of failure.
I think it's worth considering in general, although depending on which dims we're talking about, it might end up defeating the purpose of our adding the dim. Like we've talked in the past about adding a dim to IEnumerable of T to implement the non-generic stuff, and then enumerator of T to implement the non-generic stuff, and that way people don't have to deal with it themselves. But then it becomes, and then the analyzer would start firing anywhere someone was implementing those interfaces, sort of counter to our having added it. So I'm not sure, I don't know, it might be a good idea. Maybe we should do it and have it off by default, or I don't know.
I mean, what I want from dims is the syntax that says, I want this method to be public on my type, and I want the body that's already defined over there. Don't make me copy the code. But that's a different problem. Yeah, and so activator create instance was the same, passing a value into the constructor, I assume.
Activator create instance is slightly different. That's, do you want to be able to construct? You can pass a struct today to activator.create instance as a T. This is allowing you to pass a ref struct. And Aaron has a PR out right now to make that actually work.
Oh, because we have one that doesn't return object. Okay, I was confused because I thought we only had object returning ones, but
the main benefit here is the real benefit here is that allows you to use the new constraint.
Yeah.
Was that what the compiler emits?
Yeah.
Huh. Yeah, I think in general I'm fine with that. So the source breaking change you mentioned earlier, like that's you get different behavior, but you don't get a diagnostic, right?
You'll get a compilation failure when you try to recompile, and I think I have no idea what happens at runtime. I assume you get a crash or an unhandled exception or something.
But existing binaries will continue to work because they already have a point to the right thing, basically.
No.
New binaries, if you had we'd have to test it. I don't know exactly what happens, but basically you'll be trying to box something that's not boxable. And I think that'll throw some kind of runtime exception.
Okay, so then it is also a binary breaking change then, not just a source breaking change.
Yeah. Sorry, I did both.
Yeah. I assume it'll be the same thing as if you took an existing struct and turn it into a ref struct. Like a similar, hey, wait a minute, the world just got impossible, which invalid program exception.
Okay.
Yeah. I was like, I know changing a struct to a ref struct is in FTG of things that break your program. So invalid program exception is what the CLR throws if it sees a place where the code would have resulted in boxing a ref struct. I assume the dim loader will just throw that.
But that's also unrelated to this, right? It just means if
It is. I
people
just wanted
do-
to.
yeah.
I just wanted to call it out. The very presence of T allows ref struct means that, or the very possibility for a ref struct to implement an interface now means this is one more thing we have to consider. But yes, unrelated to what's currently on the screen.
I mean, in general, it seems fine. I mean,
sorry.
like it's like the, you know, this is kind of the inverse of our normal constraints because you just allow more.
Yeah.
Which I think we have done in the past multiple times successfully. So
yeah,
it's just noise.
All of these seem fine. The concern about dims being a breaking change on ref structs implementing the interface is interesting. I wonder if that means that before we ever get around to actually using them, we've already said that we can't use them at the framework level. But that's not related to this issue. That's just
or any dim we want, we do in .NET 9.
I mean, because that was one of our points previously was, I forget, to avoid diamonds. It's like, if you want to dim, declare it in the version you declared the interface, so it's not a future diamond.
Yep, and one of the few
hard.
places one of the few places that we've not done that is with the generic math, where we said dims are a requirement for these interfaces moving forward. But then I don't think we're ever going to change those to be allow ref struct.
Yeah, and they're all, I think all of the dims we have there are static, which might change things.
They're also helped, I think, by the fact that they all use a T self. And for any meaningful implementation of those interfaces, you would need to use a T self. And with that, we can block it. I think this is what Tanner was just alluding to. We can block it by not adding allow ref struct to that T self generic parameter. So we're kind of in this, we benefit there from that recurring pattern, curiously recurring, whatever it is.
Yep. Curiously recurring interface pattern. Curiously recursive interface pattern. Yeah, whatever. T self.
Okay, thank you.
Alrighty, then I think that's all. And then Eric already left, right? But I think for Thursday we should probably take a look at the what is actually left in the machine learning one. Anybody remember?
I don't remember. I thought we were pretty close to done.
Not so.
I need to run. Thanks.
Let's make that happen on Thursday if we can help it. All right, then I see the rest of you on Thursday, I guess. Bye bye.
Auf Wiedersehen.
See ya.